So I'm really pleased to introduce Alan Muir, who's going to be giving our presentation today. I won't say a great deal about him, other than I've known him for a long time. He is basically probably the most important naval architect in Tasmania, certainly in northern Tasmania. He's always active. He keeps himself very busy with work. He's definitely somebody you want to try and chat to if you can do afterwards. And he's been a long-standing member of the Tasmanian Section Committee. So I'll leave over to you, Alan, to give you a talk. I'm not. Thank you, Martin.
I don't need any introduction now. So, happenings and mishappenings, docking and launching. I'm going to, instead of starting at the ship lift, I'm going to go a little bit more before pre-ship lift. For those of you familiar with Launceston, you'll instantly recognise this as the middle of Seaport car park. So we used to build vessels. There was a side launching slipway, and nowadays that's right slap bang in the middle of the Seaport car park, next to the graving dock, the William Hart graving dock, which is underneath the Seaport Hotel still. This was a twin screw tug Nelia, had steerable port nozzles on it.
There you go. Yeah.
One of the problems, one of the little mishaps that happened during construction and assembly of this one is because there's rather a large palm on the end of the rudder stock for the steerable nozzle, that collided with the stern tube overhang. So a little bit had to be gouged out of the palm of the stern tube, out of the palm of the rudder stock to allow it to be assembled. So that was a minor mishap, that one. But they are the most exciting launchings you can have, side launching, not only for the testing the stability of the boat, but also if you have a look at the, I don't know if I've got a mouse here, have I? Oh yeah. If you have a look at the side of the shed, a lot of people used to congregate there at launching time. When the boat went into the water, rather a large wave had come around and they didn't have any way of escaping. So it was water up to the shins or ankles, usually. Next. Vessel. Whoop, gone too far. Wongaree. Still on the side launching. As you can see, these are fixed nozzles and 3 rudders per nozzle. This was an interesting one. This vessel had about 3 mishaps to it. One, it failed to launch. It fell off the launching blocks. Minor mishap at launching. Fell over to about, it actually fell forward slightly and ended up at about 7 degrees, laying on the ground. So had to pick it up, jack it up, build new cradles and did a second launching. During sea trials, although it's not a regular type of exercise, well, first off, the rudder stocks below the neck bearing, the rudder stocks were 5 inches, talking old money, and above the neck bearing, because the rules said so, it was turned down to 2.5 inches. The builder and the machine shop tried to talk the designers into going into, because it was just a waste of material and time turning it down from 5 inches down to 2.5 inches. Tried to talk the designer into changing the size to about 4 inches. They wouldn't have it. During sea trials, going full speed astern and hard over to hard over, the rudder stocks twisted. So while we were tied up to the berth, fixing or arguing over who was going to pay for and fix the rudder stocks, the tanker Bethulia ran aground in Georgetown, a petrol tanker. A state emergency was declared and the state acquired the tug Wongaree to assist with the recovery operations. So the Boilermakers cut off the top of the rudder stock, welded on new stocks, welded them, mind you, and she went off and performed duties quite well. So that was a 3 mishaps. Still on the side launching area, Del Ritchie 1 just being launched with the launching flags. So that had been built where Petuna Endeavour is being built. So Del Ritchie was launched and then Petuna Endeavour was completed. Petuna Endeavour was the last vessel I drew by hand. It used to take a day and a half to do the lines plan, and I used to have to do that. I did that about 3 or 4 times. That'll be relevant later on. There'll be questions asked. Next one, that's what happens when side launching. So go back. That's just a little something I show the owners at launching time. Stuff happens. Yes, can be a little bit dramatic. The vessels that fell over, Petuna Endeavour fell over as well at launching time. Not that one. Not that one. That one. Petuna Endeavour on the $500,000 trawler. She fell over to about 15 degrees at launching. So again, pull them upright, jack them up, build new cradles and relaunch. That was, so there's Bluefin being built. That's back in the day when haircuts were cheap. You can see that's at the ship lift. So while the Bluefin was being constructed, the ship lift and the apron and everything was being constructed at the same time. So Bluefin was the first vessel launched on the ship lift. There she is there. You notice from original, there's the bow of the original, no anchor pockets or anything like that. And that's one of the last photos. So she's now got anchor pockets and various other odds and ends. The bilge keel cracking on the right-hand side is of interest. It was quite a nasty little episode. That's a close-up of it. Reasonably poor boilermaker skills there. They've still left all the splatter around and not a very nice looking world either. But you can see obviously it started at the toe of the world. And some people will try anything. So that's the Stephen Brown. I was asked to see if it would fit on the ship lift. It did, but there was a little bit of overhang on the front. Didn't happen, by the way. Lady Cheryl, this actually was the first boat I designed by computer. When Petuna Endeavour took a day and a half to do the lines plan each time. With this one, I had John Gallot, the owner, over my shoulder for half a day on an old McSurf. It was McSurf 1.2. I don't know what it's up to now. But it was a brilliant thing, and I reckon we went through about 20 or 30 different variations of the hull form with him sitting on my shoulder for half a day.
I do. Yeah.
And this one, you can just probably spot the undocumented modifications. So when she was designed, she didn't have a bilge keel. And if you have a look, that's what happens when you have undocumented modifications to a vessel and then you try and dock it using old drawings. You can see the sliding blocks. They're meant to go in under the hull because the bilge keel is in the way. That's what happens. When these sliding blocks, the lift will drop down, the vessel will come in, they'll lift the vessel about 100 or 150 mil, and then the sliding blocks have got ropes on them, and one of the dock workers on the other side will pull the block through, and when they hear it hit the hull, they keep lifting up. Oh. But if anything happens to be in the way, like bilge keels, zinc anodes, echo sounders, bilge keel pipes, anything extra that's been put on or undocumented, that's where the slider will hit for sure. That's Petuna Endeavour. again, undocumented modifications. It's not what we call the bat wings on the side. If you have a look at the front block, front sliding block, it's not quite in there. And if you have a look at the stern,
It's not touching.
about 2 metres from the stern, there seems to be a seam up the side. And that's because they added about 2 metres onto the stern of the boat and didn't update the lines plan. So when we docked it, the breast line, which is the line from the very aft end of the boat to the beginning of the dock, was about, the boat was 2 metres further forward, which upset the sliding blocks. As you can see on the right-hand side photo, the forward block right on the front edge. Just managed to catch the chine. Next one, this one, an interesting docking. This is a Voice Snyder tractor tug. And we'll go to the next slide. So there's the docking plan, and that's quite a detailed bit of information that you get from the owners on the right-hand side for docking the vessel. Because we had to take blades out of the Voice Snyder to do repair work on them, some of the platform's timbers had to be removed underneath the Voice Snyders to allow for removal of the blades. So you can just see the whole.
Somebody's not on mute and we're hearing lots of noises coming through. So if you're not on mute, can you please put yourself on mute?
Does that include me? They're an interesting propulsion system, but unusual stock. So they've got, just roll it to the previous screen somehow. Yeah, just, 2 minutes. So she's got three sliding blocks.
Oh, he's done it.
And these sliding blocks, because the hole's so far out of the water, they're rather skinny and long. So that's with the timbers taken out to allow removal of the blades for repair work. The finished product on the right-hand side being ready to go back into the water. These can be rather difficult to, this one was quite difficult to dock. As you can see from the plan, most of the skeg, one, it's got a very high rise of keel, and two, a substantial, well, all the skeg basically is forward of midships. And then there's a sort of a connecting bar, a sole piece, and then a stern post type affair at the stern of the skeg. And on the right-hand side, you can see what happened with the first docking. Sue load, weight distribution and sue load. That was one of the 18-metre beams on the ship lift that suffered a bit of damage, local buckling of the top flange and buckling of the web. The load at the stern of that vessel was just too great. So we bent the sole piece and created a few problems. That beam is about, I think it was from 750 deep and 18 metres long. So to buckle it up like that was quite a substantial sue load. What we had to do in the end was put a substantial bit of universal column down on the beds and provide an adjustable prop at the stern to take a bit of weight. So that adjustable prop rotates, it's laid flat, the decks drop down, The boat goes in, the ram is tilted up and engaged, and inside that tube there's a 100-ton jack, or a 200-ton jack, sorry, and that's engaged to put a bit of pressure onto the stern to take some of the weight. Even though there are sliding blocks on the side, the configuration of the skeg and the weight distribution was just too much. That's the docking. That was the final docking plan, and the finished product. You can just see this. The sliding blocks are there, quite close to the ram, and the ram's stuck in between the two nozzles. This one was interesting. The King Island wave saw unit. The steel grillage. I don't know if it's a bit hard on the mouse. Can't do the mouse. Over on the docking plan on the left-hand side, you can see the steel grillage that was put in underneath before the concrete was poured. That was poured in situ, so all the formwork was done on site. Concrete trucks came in, the base was poured, and then the walls and everything else, up to about 700 tonne. It was interesting because the footprint of that is 15.5 metres by 7.5 metres, and it was 700 tonne. They did want more added to complete the construction, but it was a bit, the weight concentration was too much for the ship lift platform. So only part of it, most of it was built at the King's Wharf, and then the top sides were completed down at Bell Bay. We couldn't launch it, we couldn't roll it with those steel buoyancy pods on the side, because each one of those weighed 50 tonne. So the concrete unit itself was, it was on Hinman, 50-tonne Hinman rollers, about, I think there was about 80 or 90 of them. And they were all positioned before pouring, so they were positioned under the grillage, the steel grillage, before it was, before construction started. And then we used 2 strand jacks, which were, strand jacks are used for pre-tensioning concrete or post-tensioning concrete. So half a dozen strands on each jack, and it pulls the strands, and then a wedge will grab, keep pulling, grab, keep pulling, that type of arrangement. There are four transfer rails, as you can see in the wharf apron. That's the big, the opening for the water to go in to operate the turbine and under tow towards King Island. This one's what I call the drug boat. It was about a 50-metre vessel that left, it was either China or Japan or somewhere, and came down Western Australia, around the bottom of Tasmania, and the Federal Police and Customs and Border Force decided to pull it up, took it into Hobart, and I think they found about $150 million worth of cocaine on board. So the vessel was seized by the Federal Police, and it was brought up to Launceston, put on the ship lift. It's quite a nice looking hull, actually. I was a bit disappointed to see what happened to it. There it is there, nice lines. Have a look at the top right-hand corner. There are 2 seawater inlets. Keep an eye on those. She's on the transfer trolley, so that was rolled onto the hard, and over about the next 12 months, when the computer wakes up, that happened. And there are the 2 seawater inlets that you saw earlier. So there's not much left of it. She was all cut up for scrap. So that's what I was saying, bit of a pity, waste of a good hull, really. Nice lines. Next one, Steve Irwin. That's in the finished condition. I actually did the heliport and the Constantina helicopter hangar up on the top deck. That was built in Brisbane. But she was down here and on the ship lift after having a bit of a, I think it was a run-in with a Japanese whaler down in Antarctica somewhere. Suffered a bit of damage and she had to come in for repairs. And you can see the sliding blocks, bilge keels, anything else that can get in the way of when you're docking the boat. These are some of the larger vessels that are docked. This one's about probably 1,800 tonnes. The dock itself will take 3,200 tonnes uniformly distributed, 2,160 tonnes on a monohull, and I think it's 71 tonnes per keel block. So it's about a 2,000 tonne lift. So when they start getting up into about 1,800 tonnes, the circuit breakers start to cut out a little bit and you have to spray them with Freon to chill them down a bit. We're restricted by draft at the ship lift as well. Not only restricted by draft, but restricted by visibility. So every docking is done blind. There's no point in sending divers down to check. You just lift them up and hope there's nothing in the way. But she was a big vessel, in for servicing, scraping the paint. Gets a little bit claustrophobic underneath. Pelican, yeah, split hopper barge. These are interesting to dock. Rather unusual. In the closed position, they fill them up and then take them out to sea and split them open and dump whatever's inside. So she had to come in to get the seals on the two hulls renewed. So she had to come in split. So there are big rams, there are hydraulic rams down inside those two hulls as well. And that's, to go back to the docking plan, that's got a slight overhang as well. But because it's the bow, it's doesn't really matter. These are some of the more modern tug designs that can cause a few problems when you're docking them. As you can see, most of the hull is a fair way off the deck. There's a rather large, as you can see from the docking plan, there's rather a large rise of keel. That's about, what is it, 1,200 mil over the length of that keel. And the skeg, the solid part of the skeg is only just past midships. There are, because of the length of the vessel, which is, what is it, 28 metres or something like that, they're quite compact. So you've got to dodge seawater inlets, zinc anodes, anything else that happens to be hanging out from underneath the bottom of the vessel. For those sliding blocks, this one was done with sliders, and also at the stern there's a side cradle. There was only room to fit in one slider. The rest was, or one port and starboard. But when you see them like that, it can be a little bit precarious. There's not much holding them up. And you can't quite see it, but those are on a bit of an angle. This was another interesting vessel. 38 metre super yacht. I designed and detailed it. It was built down at King's Wharf at the ship lift. The top sides were built first, that's all aluminium, and you'll notice it's all fitted out as well. So that was done first, moved into a fit out berth, and then we got on with building the steel hull, then rolled that outside. That was built inside and then rolled outside, and the two were married up. Successfully, I might add, even though the aluminium shrank 29 mil, which it does. And that's it. On the left-hand side, as built at Sanctuary Cove, and on the right side is a photo taken by Jack at Docklands recently. So there's been a few slight modifications up around the flybridge. They've extended the bulwark combing forward. That was an interesting one. No mishaps on that. Oh, apart from during sea trials, the owner had insisted that that stainless steel doubler plate in around the anchor would that would hold on with silicon. So we dually siliconed it on. During sea trials, that got peeled off halfway, so she had to go back up on the dock, and that was it was welded onto the hull in the end.